Here's the combinatoric problem, the problem 7 from the Baltic Way 2023. So the problem basically says that we have a robot here and it can go up, right, down, or left. But with one condition: after each move, it should turn 90 degrees to left or right. The robot returns to its starting point after some finite number of moves. It asks how many possible routes that exist that this robot can take. Let U denote up, let D denote down, R denote right, and L denote left. Now let's say that this robot starts here, and if it goes n number of moves to right in total, then since it returns to the starting point, it should go the same 3 moves to the left. The same thing is true for the up and downs. U equals D and R equals L, which means that the total length is going to be 2R plus 2U, which is an even number. But think of this. Starting from this point, it might go up, right, down, and left. Somewhat is going to be cyclic. Adding these 90 degrees up 4 times, it's 360, so it's making a cyclic turn. So the claim is that this length is going to be divisible by 4, but we have to prove it. Now let's say there's a group X, which refers to right and left, and also a group Y, which refers to up and down. Now consider the first move is from the group X. The robot makes the first move from the group X. The continuing move will be Y because it will be turning 90 degrees. The next move will be X again and Y, and so on. But since it's going to be even, we know that it's going to end with Y. This shows that the total X's equal total Y's. But we know that X is R plus L, and it equals up plus down. Replacing left equals right and down equals up, we get 2 right equals 2 up. It follows that right equals up, but right also equals left, so up equals left, and up equals down, which means left also equals down. So from here we arrive to the conclusion that 4 divides the length. Now if we just construct an algorithm which will return to the starting point and that will cover all the numbers that are divisible by 4, then we are done, right? Now think of this sequence. The robot starts at this point and it goes up, then right, up, right, up, right, up to a point. Then when it reaches that point, it will just decide to go down and right. Later, it should go all this way back. So it will go down, left, down, left, down, left, down, left, until it reaches this point, where it cannot continue to get to the starting point, but it can make 3 turns to end. The thing is that this algorithm actually works, and it generates a path for all lengths in the form of 4k. In terms of up, down, and left and right, we can say that the robot will go up, right, some amount, which is dependent on k. Then it will go a down and a right. Then it should go all this way back, which means going left and downs for a bit. And when it comes to this point, it will just go left and up, finishing the sequence. How many times it will go up and right and left and down, if you actually calculate it, is k minus 1 times. This algorithm ends the question, but there's a catch. We missed the case length equals 8, just 4 times 2, case 2. And in that case, if you try to apply the algorithm, you will get the point intersecting, meaning the robot will go to this very same point twice. See? Up right, up right, then down left, down left. See, this point was visited twice. If you try other this, you will see that k equals 2 won't work. So the conclusion is that all the numbers of the form 4k, while k is an element of the positive integer set, works except for k equals 2.